Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 670. Please turn to it. Page number 670. Today is our lesson number 74. We are going to do problem number 13 and 14, the problems that appear in the second column. The two problems that you see in the first column, number 11 and 12, we already did them yesterday on day number 73. Let's take a look at it. We are told x, y, and z are positive integers, alright, such that the value of x plus y is even. So we are told that x plus y is even. And the value of x plus y squared plus x plus z is odd. Let me rewrite it properly so that we can have the two next to each other properly. So x plus y is even, and we are told that x plus y squared plus x plus z is odd. Alright, which of the following must be true? Now listen, in a situation like this, it's always a good idea actually to understand what they're telling you, to analyze this thing a little bit before you look at the answer choices. Don't look at every single answer choice and ask yourself whether or not that's true, because that's going to be very annoying. Let's analyze it a little bit. Let's put some thought into it. Let's understand it a little bit, and it'll make it easier for us to spot the right answer. Here's what's going on. We are told that x plus y is even. So for example, if it's 6, then 6 squared is also even, because even times even is even. And this is something you don't have to memorize. I don't waste your time trying to memorize this thing. Just do it out. It only takes 2 seconds. 2 plus 4 is 8, which is even. So this part we know is even. Now think of this as one part. Okay? Think of this one part. Since we are told this entire thing is odd, this part is even. So we're breaking up into two parts. This is one part. I'm calling that the second part. This is the first part. The first part is x plus y whole squared, which is even because x plus y is even. So x plus y squared is going to be even. If this is even, but we are told the sum of this part and that part is odd, how is that possible? If you have an even number, let's say 4 plus something equals odd, let's say 7, the only way that's going to be possible is if this is also odd. In other words, even plus odd is odd. Because even plus even would have been even. 2 plus 4 is 6, is even. That tells us that this must be odd. This must be odd. Now, let's analyze that part. So we're done with that part. Now, that tells us that x plus z must be odd. This quantity has to be odd. In order for the sum of these two quantities, x plus y squared, which we know is even, and x plus z, and the sum of these two quantities to be odd, the second part, x plus y, has to be odd. Has to be odd. Now let's analyze that part. How can the sum of the two numbers be odd? The only way, this implies that the only way the sum of two numbers can be odd is if one is even and other is odd. That's it. Think about it for a second. The only way the sum of two numbers can be odd is if I'm holding two numbers in my hand. If I tell you that I'm holding one number in my right hand side and another number in my left hand side, and I tell you that when I add them up, I get an odd number, the result, then either this one is odd and this one is even, or vice versa. They cannot both be even and they cannot both be odd. It is impossible for both of them to be odd if their sum is also odd. Because if they were both odd, we know that odd plus odd, 7 plus 7 plus 3 is even. Odd plus odd is even. And so is even plus even. 2 plus 4 is 6. Even plus even is even, and odd plus odd is even. Which means they cannot be both even, they cannot be both odd. One of them has to be even, other one has to be odd. Now let's look at the answer choices. The first statement says that x is odd. Now that we cannot tell for sure. We cannot say for sure that x is odd unless we know for a fact that y is even. The first statement only says that x is odd. That's not necessarily true. The second question says, so we're going through the answer choice again one more time. So this is what we're looking for. The sum of x plus z must be odd. That is possible. The only way the sum of x and z, that's the only way the sum of two numbers can be odd if one is even, the other one is odd. Doesn't matter which one is which. Okay, let's look at the answer choices. Let's look at the answer choices. Excuse me. Answer choice A says, x is odd. But that would be true if we know for a fact that y is even. But we do not know that. Not y, I mean z. If x is odd, only if z is even. But we are not told that part. This part is not there. We cannot assume that. So without that, it's not true. Well, I shouldn't say it's not true. What we should say is it's not necessarily true. It may be true. X may be odd if z happens to be even. Second statement says x is even. Again, we do not know that for a fact. X could be even if z happens to be odd. But since we are told nothing about z at all, the second statement is also something that is not necessarily true. We cannot make a statement that answer choice B is wrong. No, that's too strong a statement. We cannot say the answer choice B is wrong. What we should say is that answer choice B is something that is not necessarily true. Those are not the two same thing. Those two are not the same statement at all. It may be true, it may not be true. It's not necessarily true. C says if z is even, but we already know if z is even, x would have to be odd. Then x is odd. Voila, that's it. That is something that would have to be true. That would have to be true. Indeed, they go on to say that if z is even, x times y is even. That's just nonsense. That's just rubbish. And x times y is even in answer choice E, which is rubbish also. The only thing that has to be true, we already know, is this part right here. Between the two here, between the x and the z, if one is odd, the other one has to be even. That's the end of the story. The answer is C. Let's go to 14. Number 14. We are told that x is between 0 and 1. Which of the following statement must be true? Again, you must emphasize that key word, the most important word here. The most important word, the one word that is the most important word in this question is must. Which of the following must be true? Alright. Why don't we plug in some value for x? Let's make our life easier. Let's pretend some value for x. Let's plug in some value for x. Let's pretend that x is equals to, let's say, between 0 and 1. Let's pretend it's half. That's the happy medium. Let's pretend x is half. The first statement says x squared is more than x cubed. Do you think that's going to be true? The answer is yes, it's going to be true, because when you take a square of a fraction, that square of a fraction is going to be bigger than the cube of the fraction, because whatever the quantity is, whatever the answer happens to be, when you take a square of it, by the time you take a cube of it, you're taking another fraction of it. In this case, we're taking half of that quantity. For example, x squared is 1 half times 1 half. A half of half is 1/4. And of course, 1/4 is greater than 1 half times 1 half times 1 half, which is 1/8. And 1/4 is greater than 1/8. The first statement is true. First statement is going to be always true because of the fact that x is a fraction. Whenever you have a fraction, as you multiply it by itself, it gets smaller. Multiply the product by itself again, it gets smaller. It gets smaller because you're taking a fraction of a fraction. If you take a half of half, the result is going to be less than half, because half of half is a quarter. If you have a half a pizza and you agree to give me half of that half, well, now you have a quarter, I have a quarter. Do you understand? So first statement is true, which means the correct answer, whatever it is, must contain statement 1 in it. Must contain 1 in it. A, B, C, D, E. Well, A has 1 in it, that's good. B doesn't have 1 in it, it says 2 only, that's not going to do the job. C has 1 in it, so does D, and so does E. Alright, let's look at statement 2. Statement 2 says x is more than x over 2. Let's find out what x over 2 is. Our x is 1/2. 1/2 over 2. 1/2 over 2 is 1/4. 1/2 over 2 is 1/4. And 1/2 is 1/2 greater than 1/4? Of course, 1/2 is greater than 1/4. Again, when you divide it by 2, when you divide anything by 2, you're basically taking half of it. So obviously, whatever the original quantity is, if you take a half of it, the original quantity is going to be bigger than half of the original quantity. X over 2, here, x over 2 is same as x times half. So you have your original x and you're taking half of it. And if you take a half of it, then obviously this quantity, x over 2, is going to be less than what you started out with, which is the x. Second statement is also true. Second statement is something that is also true, which means the correct answer, whatever it is, must contain statement Roman numeral 2 in it. Let's see what we can cross out. We can cross out A now. A is gone because A says 1 only. We can cross out C has 1 and 2 in it. And we can cross out D. It says 1 and 3 only. That's gone. The contest is between C and E. Let's look at E. Let's look at statement number 3. It says x is greater than x cubed. Of course x is greater than x cubed because this is 1/2, this is 1/2 times 1/2 times 1/2, which is 1/8. And half is more than an eighth. Therefore all of those three statements are true. The answer is E. This is also true. The answer is E. All of the three statements are true, because of the fact that it's a fraction between 0 and 1. I will see you tomorrow, okay? Bye now.